Hey there, welcome back to the channel. And from the thumbnail, you must be pretty aware that, yup, made a mistake in the designing part of our block, and I will explain what I messed up. So what happens is that when we have a free block inside the free list, so free list is a linked list that has a bunch of free blocks. So what happens is that if you explain on a whiteboard, it's better. So let's say I have a free block. Well, the free block, my current free block has like four portions. So this is size, this is pointer, and this is size again. And this is the actual space that we have to return. This pointer points to another free block, let's say a similar kind. This is also size, pointer, size, and space. So if this is 100 bytes, then this 100 value is stored over here and over here too. Why why twice? Because of header and footer. It will help us in coalescing. I will explain you later on. So, but the main gist of things is we are only storing the pointer which like points to the next free block. What did I mess up? So today, while just thinking now, like how am I going to sorry, how am I going to implement the free function? I was just thinking like, okay, I have to like implement the coalescing part. Well, for coalescing, I have two, you can say, uh, like multiple different scenarios. So let's say my block one. So let's say this is the contiguous memory. Let's say we have a contiguous memory like this, right? This is, let's say this is free, this is allocated, and this is free again. So let's say this was allocated. Okay, let's say we decide to free up this block. Well, it is very it's like beneficial to us to like merge these because these are like side by side. They are adjacent. So it will be better if we just merge them. So we'll just move this pointer over here and some value changes here and there, and that's it. All right. But let's say this was allocated, this was the free one, and this was allocated again. So let's say we decide to free up this one. Well, the same thing. If we free up this one, we'll just merge these two. But the thing is that what if the block number one and block number three are free and only two is allocated? Well, if we decide to free up the block number two, it is very important for us to like merge all of them, right? Because we have to like all of them because like it will like reduce external fragmentation by a lot. So we have to merge all of them. But to merge all of them, let's say we decide to merge 1 and 2 first. Well, that is fine because 2 doesn't have a free pointer of itself. 2 just looks like this currently. Since allocated blocks don't have a free pointer, they just have a size value, and the actual space, right? And allocated blocks looks like this, where they have size, pointer, space, and size. So when merging with this has four sections. This has only two. I will, sorry, yeah. And we can just like keep the pointer at the same space, like same position, and just override these things, and boom, we have a new big block. And then we will just merge them. But wait a second, this is a free block too, right? It has like its own free pointer. So let's say we decide to like we have to keep one of the free pointers, either this one or this one. Even if we decide to keep either of them, what we have to do is that we have to make changes in the free list. Let's say we decide to uh, keep this one. Well, then we have to make sure that this block, the current this one, like only this part, this free block, let's say it was like this, This was block one, this was block seven, eight, right? If we decide to use the block one, my bad. Let's say we decide to use, yeah, my bad explanation. Like, very sorry. Let's say we decide to keep one and we decide to merge three, like we decide to overwrite three. So let's say three was in the free list, like seven, three, and eight. Well, somehow we have to make it so that the free block number seven points directly to the free block number eight, thereby skipping the three because three is now the most. But to do this, we need to have access to the previous block of three. But we just have access to the current three block and its next blocks. But we don't have the access to its previous block. Well, that is a bummer. So we have to also allocate a previous pointer over here. That's what we have to change the designing. So our free block no longer looks like this, where previously it had size, pointer, space, and size again. Now it will look like this, like that. Sorry. Now it will look like size, previous pointer, I will just keep next pointer or whatever. Next pointer, space, and then size again. So this is what our new block will look like, and we have to make a lot of changes in our code. But I guess it's fine. It's fine. It's better that we found out this like earlier, right? So let's get started. I think this change might take some like it. I don't think it will be completed in this video itself, but we'll try. Uh, I'm not sure where to even get started this because this is like a very big change. But okay. Uh, yeah, screen capture. Yeah, visible. So wait, where's my yeah. Boom. Yeah. Okay, okay. So and then allocator.c, we go over here. So this is where it all starts from. This is a void pointer. This is traverse free list. Well, it shouldn't be like we have to make a lot of changes over here, like in this. I guess it's better because I had to refactor this code like someday because like just look at this malloc function. It's like so big. Oh, this is so bad of a code. Now that I think about it. Sorry. Okay. So let's make changes in the traverse free list now because that's what we started with. Traverse free list was the first function that uh, we just you can say started with. So we don't need this previous block right now. Let's try to create our own. Like so we'll keep this for like references and all. So we are giving it void free pointer as this and requested size. So now we'll create a copy of it. So void copy free pointer is equal to dereference free pointer. This is fine. Or I could have just like copied this. Oh, my bad. Yeah. Okay. So now we don't need a previous block because we already have that. Let's make it sure like what kind of designing are we going to use. I think I will go with like size, then next pointer, then previous pointer, and then space and size. Because like it will be like similar to the like original thing, you know? Yeah. So let's do it. Let's keep the next pointer first and then the previous pointer. I'll just rewrite it on the board. So next and then previous. Next pointer, previous pointer. So, while copy free pointer is not equal to null, sorry. So, this is visible, right? Yeah. So let's get started. So let us continue. Wait, what do I have to do? I don't have to keep track of. Uh, okay. We do need the previous block for like moving the free pointer, right? Yeah, okay. How about we not change the traverse previous at all, right? How about we don't do that? Like with previous block, it's not that big part. So previous block. Hmm. I have to change a lot of things. I still have to change a lot of things. Let's keep going. So so void free pointer. So when we are iterating, we need next block. We do need this and this one too, and this one too. Okay. I guess most of these things are like fine. Now that I think of it, no point in like making anything other than let's see. Okay. Okay. 100. Yeah, we just remove this. Instead of this, we can make it so like the previous block is like so like void pointer. That's this way. So void pointer previous block will be equal to well initially will be equal to null. There's no question in that. But okay. Okay, so next block, this, yeah. So previous block, three pointer should point to next block directly itself. And we have to change one more thing inside this. We have to change the, uh, so how about I make a different function, like a new function that will help us change the value of the previous pointer inside the next block. So let's say it's a void. Um, what if the block is not present at all? Then, hmm, that's a valid question. So if previous block is equal to none, the free pointer is points to the next block. That's fine. As I said, this is not going to be a single video. I have to think about it right now. It's fine, it's fine. Many more things we have to change afterwards. This is just like a small hurdle. Okay, so let's say I have a block and then my free pointer points to here. This points to some other block. This points to some other block. Okay, so wait, am I audible? Yeah, I am. So, free pointer points to here, and then this, and if we decide, okay, do this, the previous pointer points to here. If I decide to move this one, the free pointer not should point it here, which is what this line does. That's fine. But now the next block, the previous point of the next block should now, So now we can say like next block. Yeah, we can add another thing over here. So this pretty easy. Why are we doing this? I'm not going to explain. It's like a lot of things. This is basically like we eating up the next pointer and previous pointer space to get some extra space. Yeah, that's it. So free pointer is now points to next block, and then we have to change this to none, right? What if next block is null? I have to worry about over here. That's what I'm thinking about. This is fine. We can just change the value over here. Which is like I have to go like this. So like let's say our structure is like structure is temporarily. I'm just writing this. Structure is also size plus next pointer plus previous pointer plus space plus size, right? So we can just make it so like and next block points to the new block and copy pointer will eventually move to the next block. And we can make it so like if moved over there. So let's say next block, boom, we are at that position, and then we dereference that and make it a char pointer so that we can move a bit more freely. We move by pointer size ahead, and then we change that value. We cast this into uh, no, we don't cast it into anything. It's just void pointer. We do have to do that. So let's consider this as void pointer to a pointer, and we will say like void pointer to a pointer. Next, well, we could have just said it's the next block, right? Previous pointer of next block, right? Previous pointer next block is equal to this, right? And then we see like dereferencing the previous pointer of next block is now equal to null. This is pretty experimental, right? Let's remove this. So like uh, getting the pointer to the previous pointer of the next block, making the pointer to point to none. Yep. So this is the new one. So now it will point to none. That's cool. So this is done. So now else part. This is where things get tricky because this was like fine in a linked list where we don't care about the you can say what is happening. So like let's say for example the last block was the appropriate block. So what will happen over here is that the previous block will now point to the next, so the dereference next block, which is like null directly. So that's fine. But now we have to check that if this is the appropriate block, which is the middle block, the next pointer doesn't necessarily like point to the next block. Oh, we have to add a conditional over here. Oh my God. We have to add a conditional. We have to add a condition over here. That's going to slow things a bit. So if previous block, okay, that's fine. So if, yeah, condition, if uh, appropriate block, yeah, if appropriate block is the last one in free list, if it is the last one in the free list, then the previous pointer is like nothing. Um, wait, I don't know. I don't have to change anything, right? So if this points to null. Wait. So this is like the last block. It has five sections, and this is null. So the next pointer points to null, and the previous pointer points to something. That's fine. I don't have to change anything over here. Well, that shit was easy. Sorry for saying that. So this will point to null, and I guess that is it. The previous pointer points to that thing. Yeah, da, 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 da. Oh, not that. Bad. Yeah, I guess this is fine. Okay. So this is it. This is our traverse free list now. I guess it's working. It looks big because of like I don't know, just previous block. So previous block, if previous block is equal to null, yeah, this is fine. This is fine. If this is the first one, then I have to make it so this is the middle one. Wait, I have to still make some changes. Yeah. I have to make some changes only. So if appropriate block is middle one, if appropriate block is middle one, so like the next is not null. So if pointer to next block is not equal to null, if it does not point to null, that means it cannot be the first one to. Yeah, this is fine. So the middle one. So in that case, my next pointer shouldn't only like the previous pointer. This is fine. My previous block should now point to the previous two. Okay, this is confusing. Pointer to previous pointer to the next block. Let's take this outside. Oh, I can't. Okay, wait, what's happening? Moving this. Yeah, this equal to. Okay. Yeah, got it. And previous pointer now points to null. That's fine. If not, then we'll make it like the previous pointer to the next block is this, and it should now print to the previous block itself. So previous pointer to next block, previous pointer of next block will should now point to the previous block itself. Next block points to previous block. This point to the next block, the previous block. The previous block's value has been changed. Wait, so we got previous block. We changed previous block. Previous block now points to the next block, and this will now point to previous block. This is fine, right? So previous block is a void pointer. Previous pointer to the next block. Okay, it's getting confusing a bit. 26 minutes in. Okay, so previous, so previous block. So over here, previous block. We changed the value of what previous block points to. We got like next block. So we say that the previous block is a pointer to a pointer, right? Then we dereference it. Then we just get the value of it. Right? The point in that. And what is the next block? Just a value inside it. Wait, let me draw. That would be like better for me to like visualize. Let me think out loud. You guys can see it. So what I'm saying is, sorry. So let's say this is a block. It has some sections, 5 sections as we have decided. The next pointer points to this block, which is over here. And not this position, but okay. So this points to over here. And let's say this next pointer points to over here, right? And we decide to remove this block. So now we have made it so that the next block, so in our code, we have wrote next block is, yeah, copy free pointer, pointer to pointer. Yeah. And previous block is what? It's a void pointer. Yeah. Cast it into. Okay, okay. Yeah. Okay. So let's say our pointer is over here now, and we decide to remove this block. So the previous pointer of the next block, which is this should now have this should now have the value of this here. Or you can just take it from here. That's fine. You can just take that value from over there. That's fine. That's cool. Yeah. A copy pointer is currently at like the next pointer, right? So you can just take value from over there. We just remove it by 8 bytes forward. So yeah. So previous pointer to the next block, it does not directly point to the previous block. So what we do instead is that if it's the middle block, somewhere over in middle, like then we can make it so like but we already have the previous block, right? The previous block is like the next. It's like let's not go that way. We just cast it. Come on, it's fine. Oh, do I have to do that though? So previous block plus that make a pointer. We have to get the address of it. No, let's not do it. Let's instead make it a little bit more elegant. So copy free, we are currently at copy free pointer, right? So previous pointer, previous block. The naming is getting so confusing right now. Okay, so previous block. We have to change the naming. Let's instead of copy free pointer, let's make it current. How about that? So current copy free pointer current dot current current current. Hmm. Sorry. Okay. I have to like add a naming convention. So previous block is basically like next pointer of previous block. That's what I should call it. So wherever I'm saying like previous block, how many is it? One, two, yeah, 7 instances. Let's change the name. So previous block, next pointer of previous block, next pointer of previous block, next pointer, previous block, next pointer, previous block, next pointer of previous block, next pointer of previous block. Yeah, this is fine. So the next pointer of the previous block is none. So previous pointer of current block. So that's what we will call it. So void pointer, previous pointer. Let's cast it into void pointer to pointer. So previous pointer current block. So this is previous pointer of the current block is equal to, then we have to cast it, and we have to move our copy field pointer by like pointer size. So char pointer current block, yeah, current, we move it by pointer size forward, then we, yeah, pretty much that, and we get the value. So dereferencing that. So this is dereferencing previous pointer of current block. Boom. And also I will change the name of the next block. Yeah, that is also important. So next block, 9 instances. Wow. Okay. Yeah. So next block is like uh, what we can say. Like next block, like how many times we got it. Yeah, next block. We will say like next pointer of current block. Yeah. Next pointer of current block. 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 This should be pretty clear now. And also current is not like directly current. It's like the next pointer of current block. Current. That's fine. Yeah, the naming convention is pretty confusing right now, but it's fine. I think this is it. We have successfully made some changes inside the, you can say, wait, we haven't made any significant changes to like this, right? So this should compile. Let's try that. Let's comment this out. Boom, make, and we will have some errors eventually. What? No errors? And driver dash C. Seriously, no errors? Come on. Yeah, exactly. Wait, ran out of memory. That must be like because of, yeah, yeah. I got it wrong. So printf, what was I going to say? Yeah. So there is no free, like there is no free function. So nothing is going to be appended into like the free list. So we will eventually end up inside this if condition. So yeah, I'll just write so print uh, size. Let's say size is schedule, and then we have aligned size, which is zero again, and then we have let's say block not found in block not found in free list calling SPRK. And then boom, a new line. This is one more new line. Yeah, that's fine. So now first we have size, and then we have bind size. This should work. So this make parameter C. Yep. So I guess it's working. We are not finding like any block, so the code is working. It's not like if I would have written like anything. So we are not basically like we are just ending up over here and then we are skipping. So none of our while code is getting like checked. It's returning the thing. So yeah, we have to check it somehow. But okay, I guess this is it for today's video. Let's end it over here. So our traverse feelers function, the working of it is done. Mallet will be a big one, but I guess we'll do it. Not a big deal, but okay. So what do we have to make changes in? We have to make changes inside the no idle block found. So if no idle block was found, we have to call this PRK, and we have to not only ask for align size, we have to make size t size. Yeah, this is fine. We have to just keep it this one, and then yeah, new block will point to will be align size plus one. That's fine. This is fine. Yeah, pretty much don't have to change anything over here. Yeah, if this is found, yeah, it is size pointer. Yeah, we have to change a lot of things over here. Yeah. We'll cover this in tomorrow's video, but this is fine. So, okay. Um, I guess this is it. Thanks for watching this video. I'm Adit Pachane, and I'm an engineer for fun. Bye.